Hi, everybody. Welcome to another session of Come Cloud with Us. My name is Abdul Kazi, and I have my co-host, Chris Gale. Hey, Chris, how's it going?
It's going well, my friend. It's going real well here.
Good, good. You're looking forward to fall,
Oh, I
I guess
am.
summer, almost end of summer.
I most certainly am. I already, I think we all got the marketing materials, the pumpkin spice, whatever, everything. So, we're getting like, hit me with some donuts, get me some cider, some of the good fall stuff here in upstate New York, some apple pie, all that. What? Yep. Yeah,
Nice,
you can tell what
yes.
I'm driven by. So, donuts and coffee. But
Oh, it's coming up. Oh, trust me, it's the same thing in Canada too. We're looking forward to Halloween and all that stuff. So yeah, it's the weather drives it. So yeah, yeah.
awesome. Awesome. Awesome.
Anyways, we have a great session for today. So we have Samson from Nigeria all the way. Thank you so much. First of all, appreciate it because I know it's midnight over there. So,
Yeah.
uh, you know, uh, do really appreciate you coming on and sharing your knowledge with us. With that being said, I'll let you introduce yourself, kind of talk about yourself, how long you've been in the IT arena and your expertise.
Okay, hello everyone. I am Samson Amaugo. I am a software developer and a full stack developer too. I'm also a Microsoft MVP. So I've been coding for quite, I think, over 5 years. And I have experience in some DevOps tools, some backend, using some backend technologies. I have also experience in some front-end technologies. It's glad being here. It's glad talking to you guys. And also, it's an honor to be given this platform to speak and present.
Yeah, very nice. And we'll let you kick it off with the presentation.
Okay, so today we're going to be looking at what is called Orleans. So we're going to be looking at deploying and scaling Microsoft Orleans in Azure Kubernetes Service. So what exactly is Orleans? So Orleans is a framework used to build distributed applications, mostly using the actor model. And the idea of the actor model is that you have, lots of small pieces of objects or actors or entities that communicate using messages. And these entities or actors they can encapsulate both states and behavior. Orleans does a lot of things under the hood, like it manages fault tolerant scenarios like activation of grains on a new node when the current node is not available. And also it enables developers to write in a single threaded manner, thereby um, overlooking some of the complexities. It abstracts some of the complexities involved in writing distributed applications or in distributed computing. Now, these are some of the areas where you could actually use Orleans. You can use it in real-time gaming applications, financial services like trading, applications, IoT, logistics, and supply chain. And using this helps to, improve throughput and concurrency. Now, the next thing we're going to be looking at here is AKS. What exactly is AKS? So AKS is just an acronym that stands for Azure Kubernetes Services or Service, and it is a service that is offered by Microsoft Azure as a managed Kubernetes service. So you don't have to worry about managing the infrastructure of your containers, your nodes. You don't have to worry about that. Azure manages all this for you using the AKS service. So let's look at why you'd want to deploy an application in AKS. Number one here, we have scalability. So in scalability, using AKS can easily scale your nodes, can scale your application globally across multiple computers. It also enables you to easily manage your services using a simple tool called kubectl. And you can also leverage security in Azure by using AKS. And the last thing I have here is easy integration with Azure services. So when you're using AKS, it's easy for you to integrate with those already existing Azure services. Then when there's one thing we're going to look into, and that is Orleans Kubernetes hosting extension. So this extension enables you to, easily integrate Orleans in the Kubernetes environment. So the next slide I have, why is the Kubernetes hosting extension rather than only rely on the membership table? And these are some of the reasons of using the Kubernetes hosting extension. The first thing I have here is automatic configuration of silo names or silo names. The second one here is seamless integration with Kubernetes service discovery. And the last one here is automated detection of dead silos. So when deploying in a Kubernetes environment, you don't want to only rely on the membership table. You want to also plug into some of the existing infrastructure and capabilities of Kubernetes, and that is where the hosting extension comes into play. So let us get building right away. So we're going to build a very simple solution. The aim is just to show you how to configure your Orleans application for AKS. So here with me, let me zoom into my screen. I think the zooming is okay. So here on my screen, I have a simple Orleans application, and it's bootstrapped using the new tool on the block, which is Aspire. So with Aspire, you can easily set up different tools and integrations without the lot of things. It's just like I'll call it Docker Compose on steroids. So let's just run this application, or let me explain what is here first. So here on my screen, I have a Redis container. I'm trying to add a Redis container into this architecture. And this other line, I'm trying to set up Orleans services or integration. And then here is where I have the project that I'm building. This is just a simple API. And with this extension, with reference extension, I can connect the Orleans services into it so that it could have access to some of the environmental variables needed for deployments. Then this final line here, the one called with endpoints, is a line that adds Orleans dashboard capability so that I can have like an eye view into the services, the silos running, the grains running, and some instrumentations in my Orleans architecture. So let me run this application. Click on run. It will take a while to load. Oh, there seems to be an error with my Docker. But let me restart my Docker a minute. Okay, my Docker seems to be running. So let me run the application again. Awesome. So my Aspire dashboard is up and running and it's setting up the required services. So you can see here, I have my Redis container running and I have 3 instances of my Orleans application. So you might be wondering why I have 3 or how I was able to integrate it. So Orleans enables you to also deploy it using a co-hosted style. So what I mean by co-hosted style is that I'm co-hosting this Orleans server together with my ASP.NET API. Let's go back to the dashboard. And if I click on view here, I can see some of the endpoints available or exposed. I can also see some environment variables configured automatically by Aspire. Okay, so everything is running. So to view the dashboard, let me go to my code and show you. So this is where I configure the dashboard. So to access the dashboard, I have to go to this, navigate to this part. So let me go back to the dashboard. Yeah. 977, click on it. So I set it to be on the dashboard part. So this is where I have my Orleans dashboard. You can see that I have my silos, my replicas, which is 3. So everything seems okay. And currently I only have the management green and dashboard green. And that is because looking at my code here, I've not sent a request to my payload green. So for me to activate this green, I have to like send a request to activate it. So let's try a sample request on this part. Try it out. So let me say Samson. So I'll click on execute and you see it returned here, good day, Samson. So if I check this dashboard, you see that the hello green has been activated and it just has one activation. For me to have multiple activations, I have to use different names. So let me change this name to Chris. So I'll click on execute. Okay. And start spinning again. Okay. Okay, so you can see I have 2 activations of my hello green. So Orleans handles automatic activation and deactivations of these screens. So you can see this is what we have that we're going to deploy to AKS. This is just a simple Orleans application. This is what the green looks like. This is just a hello green. This uses dependency injection to have access to the client. Then it accesses the green and it passes this variable as an argument into this color, the say hello color. So that is what we have to deploy to AKS. So the next step here would be to look at what the configuration for AKS would be. So this is what the manifest looks like. I would explain it. But before I explain it, I would want to show you what the manifest generated by Aspire would look like. So I got a hint of some of the variables that I would use or set up here from the manifest created by Aspire. So to generate that manifest by Aspire, I would head over to the app host directory. So I'll click on open in terminal. And after doing that, I'll run this command. Actually, .NET run, and I'll set the publisher flag the manifests, and then I'll set the output part of my manifest. So I'll say aspire manifest.json. I'll execute this. And this command will generate the manifests of my Aspire application. So with this manifest, I would have an idea of some of the variables that I'll set up in my Docker, in my Kubernetes YAML configuration. So the manifest has been generated. And in this manifest, you can see it has like a definition of the environmental variables, the HTTP bindings, the silos, the gateways, and whatnot. So this is what I use to like have an idea of some of the variables that I would use in my Kubernetes configuration. So here with me is I have my deployments. So for my deployment, I'll be configuring just the API. I'll name this deployment API. And here you can see I have the rolling updates strategy set to configured for max unavailable and max source. So the max unavailable is 0. So I set it to 0. This is like the default configuration for Linux docs. So when you set the max unavailable to 0, what happens is that when a rolling update occurs, before a container can be disposed, a newly created one has to be up and running. So this makes it to be highly available. Then here I just set it to 2 replicas to test. And then this is where I define my API label. And okay, so now for me to actually use this, extension, so this extension is what enables the easy configuration of all links to Kubernetes environments. So this extension requires you to like inject some environmental variables for all links to be able to perform efficiently in the Kubernetes environment. So some of the variables needed, some of the settings or configurations needed is the label. So this this should be all lanes. So this all lanes slash service ID and all lanes slash cluster ID should be set as the container label, the pod label, and you should also set configure the pod namespace. You should also configure the pod name. You should configure the pod IP as an environmental variable. So these label, these two labels, and then these 3 environmental variables are essential for this Kubernetes extension to work properly for lanes. So I set it using like the deployment data variables, which I got from using the metadata namespace and status pod IP. So the next thing that I configured here is the service key. I set it to Redis. So Redis serves as my membership table here. So I configured it to be set to Redis. And I configured the connection string for Redis to be gotten from the secrets. So I have a secret, the key connection string. And then I set the Orleans silo dashboard to run on port 8000. Then the next thing I set here is the .NET shutdown timeout seconds. So this makes it to gracefully shut down when maybe you want to scale down or scale up your container. Then there are some important ports that you have to expose, like the 3000 and this 30,000 and the 11,111 ports. They're exposed for the Orleans gateway and silo ports. And then these other two ports, expose them for the dashboard and the ASP.NET API. So here with me, I have the load balancer configuration. So this enables a load balancer to be configured for this service. So you can see in this service, this API service, I have two ports exposed, this one and this one. Next, I have my Redis deployment. Although this should, in a real kind of content, this should be a stateful set actually for data persisting services. It's usually better to set them using stateful sets. Then here is my secret. So this is where I define my secret. So this just establishes or defines the connection string to Redis. And this is where I defined my Redis service. Then one final configuration that is paramount for this extension to work is row binding. So the links extension, Kubernetes extension requires this get access, the watch access, list, and patch so that it can efficiently monitor ports and silos in your node or cluster. So these verbs enables us to make requests to ports, so it can patch, it could list, it could watch, and it could get ports. Then this is why I define the bindings. I set it to be under the default service account. So that is why if you check here, I didn't really define the service account for this deployment because in my row binding, I just set it to be under the service account, default service account. So the next step, we're going to look into creating your AKS cluster, building the service using Azure Container ACL, Azure Container Registry task, and we'll also see how to link the ACL to AKS so that AKS can have access to the private registry on Azure Container Registries. And finally, we'll scale it up and see if it's actually scaled successfully. And the last thing we'll do would be to define an egress for easy access. So let's get into it. So I want to be in the root here. And I want to set some environments, some variables in PowerShell. Let me push this to GitHub. Make some this. Okay. So the first thing I want to define here is my resource group. So I'm going to create a default resource group so that I'll not have to always type the resource group when typing out these AC commands. And also for the purpose of this session, we're going to make use of Azure CLI tools so I can just have a view of what actually goes on, how to set it up step by step. But in a real production environment, you might not want to type it out. You'll have to use things like GitHub Actions for CI/CD, maybe make use of Argo CD for GitHub's operations. So let me set the default resource group and also location. So config set defaults. Then I'll set my location to East US, and I also set my group. I'll call it Orleans group. So let me be sure that this default setup has been configured successfully. So you can see I have it defined properly. So the next step would be to define my culture variables, which I'll use. So the first thing I want to define here would be, I want to define my resource group. So I'll say RS group. RS group would be or links group. Yes. Then the next thing I want to define is my cluster. So I want to define my cluster name. I want it to be Orleans group cluster. The Orleans group cluster. And is there anything else defined? Yeah, I think that is all for now. So now that we have this running, let's create the group. So I'll do AZ group create. Then I'll say resource group, arrays group. So this command would create the resource group that we're going to be using. Yeah, so the group is created. Next, we are going to create Azure Container Registry so that we can use Azure Container Task to build our image. So I'll say ACL create. Let me say registry. Then let me call it. Let me define a variable for this. ACL. I'll call it my registry. And I'll say ACL create name ACL. Then I'll select the standard SKU of the ACL. So it takes some time to load or to set up. Oh, this name has already been collected by someone. So let me change this to my Orleans registry. My Orleans registry. Let me run it. Okay, cool. So we have our ACL, Azure Container Registry set up. The next thing would be to use the Azure Container Registry task to build our image. So I'll say ACL build registry ACL, and I'll define the image tag. So I'll call it API v1. Then I'll set the location of the Docker file. So this is the Docker file that I'm building here, just this one for the .NET API. This is what I'm building. Then I'll run this command and give it some minutes for it to build the image. Oh, I made a mistake in my build spelling. Oh, another error. Let me fix this. I need a double. I mix this. Yeah. So it would like collect the folder directory contents and use that to build the image. So it's building. Cool. So our image has successfully built. The next thing we're going to do here would be to create Azure Kubernetes cluster. So first going to create. So when creating your cluster, you have to create the control plane nodes and the node app nodes for user applications. So and the node pool nodes for user applications. So I'll type in this command to create system the system mode or control plane node. So I'll use this command name as a cluster name. For this session, I'll just set it to be in one node cluster, just one node. Then I want it to have a load balancer so that I can have access to it from the public internet. Then I'll set it to use the standard load balancer. Then I'll generate SSH key for access to my terminal. And finally, for this cluster to have access to my Azure Container Registry, I have to attach the ACL to it. So with this command, I'll have the cluster up and running. So it's take a while too. Okay, cool. It's running. So as it's running, let me just showcase a just a side project that I worked on using Orleans and Next.js. So this is basically a tic-tac-toe application powered using Orleans, but it supports multiplayer gaming and also it also supports playing against an algorithm. The algorithm I used for this application is called Minimax. So Minimax is sort of a backtracking algorithm which you can use to easily know the least amount of moves that you can make to maybe win a game. It can also be used for creating chess applications. And I just used it here for tic-tac-toe. Let me open the grain. Okay. So this is the hub that controls the game. So you can see this grain as the mind of the game. Let me run it and give a little demo on it. Okay, so this is the Aspire dashboard. Aspire actually helps a lot in, scaffolding and bootstrapping your dependencies with ease. Like, I think it's a really cool tool. So I have my database migrator executed, and it has finished executing. And I should be able to start this app. So let me click on my web application. Take a while to load. So for this, you can see my web client is basically a Next.js application. So it's still building the application. So that is why it's still loading. And Aspire helped me to easily scaffold it and bootstrap it here. So you can see, where is it? Okay, so you can see here on line 20, I have my npm project integrated, and I'm executing this def command, the npm run def command, and I'm exposing a proxy on port 3000. So yeah, so it has opened. The next thing I'll click on login. So this is tic-tac-toe application. I can actually play against another user, another registered user, if I open this session on a different browser, maybe incognito mode, or I could just play against the algorithm. So if I click on computer, if I click on start game, I would see my board load. So it says don't play Sam to KY. That's my email. So I'll click here, and then the computer plays. So it's my own don't play now. The computer's don't play. The computer's play. I'll play. Computer's played. It's my turn to play. So if I don't close here, if I don't close this box, the computer or the algorithm would win. So let me wait to. Actually, either way is if I click here, the computer plays here and wins me. And if I click here, the computer plays here. So either way, the computer win. So yeah, the computer won me. So I can play again. So this application is bootstrapped using Orleans under the hood, both the algorithm and the multiplayer. So it's bootstrapped using Orleans with the aid of Signal R for real-time connection. Let's check and see if okay, cool. So back to this application, the cluster seems to have been set up. That's the control plane. Let me stop this application. Nice. So the cluster has been set up. The next thing we're going to create is the user mode node, where the bulk of the node of the workload applications will be hosted. So for me to create that out, type in AKS node pool add and cluster name. So here I'll say cluster, I'll set the cluster name of the node pool. Then I'll set the node count. The node count is 1. Then I'll set the node VM size. So I just want it to be a standard B2S computer or server. So I'll click here. Did I miss something? What is it? Node pool. Did I miss it? Did I miss it? I miss it. Okay. I missed something. The name of the node pool. So I'll say I'll call it US pool. US pool. So I think this should work now. Yeah. So I think the API has admitted it. Is now trying to set up. Yeah. So it's setting up the node pool. So this also take a while. Okay. Uh, this one is just loading. So I think I'll just show you around the code of the tic-tac-toe game. So this is for the folder structure of tic-tac-toe games. Like I have the app host, I have the service defaults, I have the API, and I have the database migrator. So this database migrator is used to set up a schema for my PostgreSQL database. So it's a worker service, works in the background, executes once, and after execution on this line, it stops. It just runs the migration once and stops. So that is for the database migrator. I also drop a link to this on the slide so you can take the code out. Then this is my API. I have three basic endpoints: my game room endpoint, my invite endpoint, my user endpoint. And then for my grains, I have my connection grain. So this grain handles user connection for the real-time streaming of game events using Signal app. And here is my game room. So in this game room, this is basically the brain of the tic-tac-toe game. So this is where it handles tons of players. And if you decide to play against the algorithm plays, the algorithm is executed in this screen. Then this is my hub. This is where I define my signal hub and logic. So it's pretty cool. It's pretty cool. And in my program.cs file, this is where I set up the basic configuration of my API. And I also expose the ports here as well. What else? What else? What else? So this is where I set up my course error, my course handling for my API, and then injected some authorization handler that will be used. One tip when you're working with authorization handler, always remember to register the authorization handler. If not, you would have a serious bug and you hit your head a lot trying to figure out why isn't my authorization handler handling the request, the authentication request, authorization request. Okay, so let me go back here. Cool. So now that we're back here, you can see that the node pool has been created. So the next thing now would be to add the context, the configuration context of my cluster so that I can be able to access the cluster using kubectl. So I would say easy here get credentials, name, and I'll just set cluster name. Boom. Yeah. So we have the cluster added. So if I type kubectl get load, You can see I have both the US node pool and this other node pool. Cool. And if I type kubectl get pods, you see I don't have any pod running. So that is where the next step comes in. So the next thing we're going to do is to deploy these resources. And to do that, what I have to do is just to cd into my API folder, Kubernetes there. And then I'll run this command, kubectl apply -f dots. So these dots means all the configs under this directory, just deploy them. So it seems like, let me see you. Let me check something. kubectl config get context. kubectl config. Think I'm missing something. Okay, get context. Plural. Okay. I also have to change my context. I think that's what is missing. Set context. Set context. Cool. So I've set the context to the current cluster. So now I think this you should be able to deploy now. So if I say kubectl apply -f, you should be able to deploy my services. Or still wasting time. Probably should be use context. Sorry. Use context. Nice. So use context is the correct command actually. So what is the problem here? Why isn't this working? Oh no. Okay. Failed to download these. So API deployments, channel. You can stick here. Say error validating data failed to download the API. But let me check if this is valid. I don't know why this error now. Live coding coming. Yeah, it's valid. So why did it even say error validating this? No such host. Excuse me, let me check something in my Azure portal. Be sure. Oh, sorry. I think I set the wrong stuff. Get context. Okay, so I used the wrong context, so that is why. So use context. Um, Orange group cluster. So run this. Cool. So the problem, I made a mistake. I was using this context earlier on instead of this, because this is actually the name of the cluster. I'll have to delete this later on. So now let's check the ports created. So kubectl get ports. So it's saying image pool backup. Why is that so? Let's see. So this is like a live debugging session. See why it's refusing to pull. So kubectl describe. I want to describe the code and just copy this. Fail to pull image. Why? Let me check the image that I pushed again. Coming. Oh. Sorry. So the problem here is that I have to set the name of the ACR correctly. So the name of this ACR is called my registry. So that is the problem here. So I have to change this to my registry and redeploy it again. So I've set the correct registry to use. So I think this should make it work. Let me save it. Push to GitHub. Nice. So run it again. Yeah. So now let's see the pod, the get pods. Why is this still here? My audience registry is the name. My audience registry. That is the correct name. Let me cross check that. I'm coming. Let me cross check the name of the registry. Okay. It's actually my audience registry. So remember when I set my registry here, there was an error trigger that this name has already been used. It's already in use. So I changed it to my audience registry. So this should be the right name. Yeah. So save it, run it again, and see if it will work. Cool. So one container is running at least, so there's hope. Let me run this command again and see. Cool. So we have our API running. Let's check the available services. So qtcl get services. You can see I have my load balancer set here. So let's test it out. Let me copy this and paste it. Yeah, awesome. So you can see the API is up and running. Now let's check out if silo, our link silo is running. So let me say something. You can see it said good day Samson. So let's also test out the dashboard. Let's test out the dashboard that was set here. So you can see I set the base part to be / dashboard. And also the dashboard is listening on different ports. And this is the port that is listening on, port 81, which I defined here in my API service. So this one is for the dashboard port 81. Let's check it out. Port 81 / dashboard. Cool. So this the Orleans dashboard, although you can use open telemetry to collect your metrics on your Orleans silo. We have two silos because we have, if you check why we have two silos here, because in our deployment definition, we have it set to 2 replicas. So we have 2 instances of this running. And let's check. So now I don't like the fact that I always have to type out 81 / dashboard. I think it will be better if I just access it using / dashboard. That is the ingress IP and then / dashboard. So currently in my setup, I don't have ingress. So the next thing to do to have like a single entry to my service is to define an ingress. So let's get into that. So let me create a file called my ingress.yaml. Yeah, cool. So I'll just paste it. I'll just paste the ingress from somewhere because I've already tried it out before. So this is the ingress. Let me just explain what the ingress does. So this ingress makes use of the web app routing Kubernetes class. So this makes use of Nginx tool, reverse proxy underneath it to enable this ingress. So anytime I access the base part, it should route me to the actual API, which is on port 80. And when I access /dashboard, it should just route me to the dashboard's hosting, which is on port 81 from the defined service here. So let me make these changes and see if that would work. So let me type qctl get ingress. So you can see the ingress has been defined, but it doesn't have any public IP. And the reason why is that when I was creating this cluster, I didn't enable the app routing add-on. So I mean, it's easier to do it during the beginning of your architecture, like setting up your architecture. But since we didn't do that, we can always update our cluster. So to do that, we are going to type in a command, which is azaks app routing enable. So this enables the app routing add-on that uses Nginx. So I'll say here cluster name. So this will take some time, some minutes to set up the ingress class so that I'll be able to make use of this ingress as the only entry point in my service. Okay, to take a while, so let's just be patient a bit.
Wow, this is a great session. Loving the demo.
Thanks. I think just making a slight mistake of spelling your email can, scatter a lot of things.
Yeah. No, we were chatting backstage. You did well on your feet because troubleshooting on the on the
Live.
right in the focus, man. Well done. So.
So this ingress just makes it easy for you to have like a single entry into your application. You don't have to worry about the multiple ports. You can just aggregate everything through this single IP. There's really some nice tools in there. Cool. So it has been enabled. So now remember, when we typed out this command, let me get it. When we typed out this command, I said kubectl get ingress. You can see that there was no address assigned to my ingress class or proxy. But now when I try to type it out again, you see that a public address has been assigned to it. So now with this address, I should be able to access my service easily. So initially, to access my dashboard, I have to like manually type out port 81/dashboard. But because of I've already defined a single entry and defined how the routing would go, I can just only type the public IP and just type out dashboard. So the routing is being handled by the university. When I type dashboard, boom, I have my dashboard loading. So you can say I have 2 active silos, and with this dashboard, I can also track how many all-in silos are running. So I could just run this command to scale it. I could just run kubectl hail think replica 32 deployment API. I want to scale it to, let me say 10. 10. Am I missing something here? Let me see. Okay, there's a mistake here. kubectl. So anytime you're not really sure about the command in kubectl, just use the help command. You see an option there. So, okay, it's actually replicas, not replica counts. So this should be replica. Set my replica to 10. Let's say, let me see. Okay, replicas, not replica. Replicas. Boom. So it has been scaled to 10. So if I'm to type kubectl get ports, you see that I have about 10 ports running. And when I go back to the dashboard, you see it's showing me live feed of the current instances of my silos. So I've come to the end of the demo. I think I've showed a bit how to deploy your Olenis application, how to use the Use Kubernetes hosting extension with your Olenis server or silo. And let me go back to my slide to finish up. So yeah, so this here is the link to the repositories. You can check them out. The first one is for this simple API to AKS, and the second one is the link to the tic-tac-toe application, the multiplayer game. And you can reach me on Twitter. I think it's now X, so this should be x.com. So you can reach me. You can reach me on x.com/swacklooms, on my blog. I write technical articles on my blog, swacklooms.com. And here's my LinkedIn, linkedin.com, Samson Amaugo. Thanks so much for having me. And also, if there's any question, feel free to ask me. Thank you.
Awesome. Yeah, I don't see any questions, but I know we have a few viewers. If there is anything, now is your chance. We got Samson online. Otherwise, again, great job, great presentation, fantastic demo. Definitely know this stuff inside and out. You said you were doing this for roughly a year now. That's so amazing. So well done, sir.
Thank you.
Yeah, so I don't see any questions coming in. Abdul, any other thoughts? Any other last minute questions here?
No, just thank you so much. This was really well done demo, and actually, I love the troubleshooting on the fly. So that's amazing. That actually shows how much you know about your stuff. Because honestly, like I would be nervous doing demos live. So, but yeah, troubleshooting and stuff, it's amazing. It shows definitely the grasp of the concepts. It's not like learning and going and clicking is different things, but then troubleshooting because you have to go and think through the process. That's amazing. But yeah, great job. I really loved it. Thank you.
Yeah, thanks so much. Thanks for having me.
Yeah,
Yeah.
anytime. I would just say my only parting thing is love that seeing you Aspire growing more and more. So that's awesome to see that in play too. Just gets people, I think, ramped up and moving a little bit quicker than the traditional tooling. So. Awesome. Well, with that, I know it's like 1 o'clock, after 1 o'clock your time. So thank you, Samson, for coming out, for doing the session. Thank you, viewers, for everybody tuning in. And until next time, this is Come Cloud with us saying have a great morning, afternoon, evening. If you like our content, smash that subscribe button, and we'll see you next time. Take care, everyone. Bye now.
Bye.